Hi, I'm Sean Hall with Sodium Dental. Today, we're going to go over something. I have a client who'd like to print gingiva mask models, also called soft mask models, for implant planning cases and also to utilize in their lab when they're doing a crown buildup and want to be able to print a model with a cutout in it so that you have a separate printed material, a gingiva mask material that's softer, that's more representative of the sponginess of the gingiva, so that you can see how your new crown will seat. Whenever I print a new material, in this case, we're going to be printing the Licrete gingiva mask material, there's always a couple of steps we want to do first, because printing is a little, it's a science. And so let's go through a couple of steps. The first thing, let me just go ahead and show you what I'm talking about, what we intend to print. So this is what we intend to print today. This is the gingiva mask model, and this will go inside of this regular dental model. Now, when you print these dental models, it's always very straightforward with the Shining printer. Slap them down on the base. If it's a hollow model like this, I would actually recommend going ahead and choosing the default supports and letting it build supports, because this big unsupported arch space in the hollow models won't just print right, and it won't turn out right. If I'm designing models using AccuDesign, for instance, with a Shining scanner, I always choose to make a honeycomb model myself. So we print this model first. That's very straightforward. What I'm going to be going over is printing the gingiva mask model because it's a new resin for us. So I'm going to open up Accuware. This is the printing software for Shining 3D. And maybe I'll just take a brief second here to discuss, if you're curious as to how to get models like this to print from a case you're working up, Shining 3D actually has digital design services. When you get a Shining 3D scanner, you also go ahead and set up a Shining 3D account. There's no fee for it. It's free. There's no ongoing subscription or anything like that. And it gives you access to your cases on the cloud, because the Shining 3D software you can upload the scans to the cloud. So if you go to s.dental3dcloud.com and log in with your Shining account, you'll basically kind of see almost like the lab side of your scanning account. If you go to design services, you'll see Shining actually offers a ton of design services. They're all very inexpensive, and the turnaround time is a day. So, you could make those models in Exocad, but you'd probably have to buy around $13,000 worth of Exocad software and be stuck with like a $2,000 a year subscription to use their software. And for me, I'd probably just let other people do the design services. The models I'm working with now today were designed by Shining 3D. So you would choose implant, and under the implant 3D model, you can see here that we have the separated gingiva mask models. And it's very straightforward. You just select it and hit next. You choose information about your case. Mine's on FDI right now. I set it to UN, so you get the right tooth numberings if you're in the United States. You select your case, just like you were saying, this off to a lab. And then once you do, select some options here. Need a jaw frame? Yes or no? No. It's pretty straightforward. And you can see it pops up and tells you, like, I wouldn't do a hollow, I would consider a solid integrated model. But a hollow integrated model is good too. Basically just changes how you print it. The analog gap, these settings are, if I'm printing with a resin, I might set this at 0.05 millimeters. A lot of their defaults are really excellent. They want to know about the software preferences you can just choose no preference because you want the STL files back for you to, it's going to send you back a whole bunch of 3D design files that'll work in any design software if you wanted to do some further design. But that's why I just choose no preference, because I get everything back. This is important because you choose, if there's going to be a scan body in your scan, if that's what you're sending off to where there is a scan body in the scan, you need to select it, because then it's important because it tells them specifically in the design exact dimensions of that body. But that's all straightforward. And when you go, you upload the scanned files, upload the upper jaw, the lower jaw, scan body scan, gingival data, and these are optional. Like some people don't scan a separate gingival data. So a lot of times you'll be just doing upper, lower occlusion scan. And if there was a scan body scan, you send that separately. And then click next and go to summary. If they need anything more from you, you just pop in here. They'll ask you questions and such. They're super easy to work with. As you can see, it's a very inexpensive design process. Okay, so let's go over how we print this. So the first thing you're going to want to do is you go over to your printer. You can see I'm actually already printing this because I actually did this whole video and realized that my sound was terrible. And so I'm re-recording it. So I'm going to have to repeat this process. But one of the things you want to do first is go to your printer, and on your printer, you can select what resin you loaded into your printer. It's super simple. It's a touch screen, drop down, select the resin manufacturer, select the resin type. So you need to do the same thing on the printer software. The reason why you have to select it in two spaces is actually to protect you. It's because Shining doesn't assume you only have one printer. You might have 4 3D printers. They might all have different resins in them. And so when you select your print file, you're going to set up a print for maybe printer 1 that's got one resin in it. And when you select it, the fact that the print file has to match what is supposedly loaded into the printer is just a protection step. It keeps you from accidentally printing something wrong. So go select your resin on your printer, come back into the software. And if it's a resin you haven't printed with before, click on all materials, select the manufacturer of the resin. You can see Shining works with a lot of resin manufacturers. So I'm using a Lickcrete Gingiva mask resin. I'm going to select the layer thickness at 0.1 millimeters. In my experience, I have not seen any advantage to printing at a 0.05 millimeter layer thickness. In fact, a lot of resins do not print very well at that higher resolution. The fact that the printer can do it doesn't change that sometimes the actual material, the actual resin, isn't capable of being printed at that high of a level of precision. And that usually has to do with optical bloom. This is very technical, probably not something you need to worry about in your day-to-day life. Just print at 0.1, okay, if you want to just take my word on it. All right, let's go to data processing. This is basically where I load in the model. Okay, so I'm going to open a case. I've got inside my case folder, I've got 2 model bases. I'm not going to print those here because I'm going to print those with model resin, not Gingiva mask resin. The whole point of this is I'm printing the Gingiva mask in a different material that's softer and has some sponginess to it. So there you go. Here's that Gingiva mask model. Now, let's assume this is the first time we're ever printing this resin. The first time you ever print a resin, and specifically the first time you ever print like kind of a new thing, not like a lot of times if you switch from, one model resin to another, if you're used to printing models in general, you don't really need to do much work here in the software because it doesn't change very much. But right now what we're doing is we're printing a very, very small object. And I'm printing a whole new resin. So I'm going to print 5 of the exact same thing. The reason I'm going to do this is I want to see what's the best way to print this to where I have the least amount of work to do after I print, the least amount of things to clean off, the least amount of touch up and buffing. Taking the time to do this once, or you could just trust my settings after watching my video. But taking the time to test this for yourself and see the results will really cut down on printing errors you have where parts fall off the print plate and don't work out right, or just other issues you might have in the future. And you just do one test the first time you're going to do something, and then write down what you did. And then after that, you just print it the same way every time. It doesn't matter if you've changed, it's a new scan, a new patient with a new gingiva mask. That won't change what we're doing here because it's still a very small object with a distinct, it's going to have like similar attributes, even though it's technically different. So the first thing I'm looking at is I've got a flat plane. And if I've got a flat plane on something, my first instinct is stick that flat plane right to the build platform. And just print it like that with no supports. So I'm going to do that with this one. And then with two others, I'm going to also do that. And I'll show you why in a second here. Because it is possible that my straight to the build platform one doesn't work out well. Some resins are really sticky. Some resins are not. I'm going to give a little space here, let it auto lay these out. I'm going to try and match how I had these in my first video so they make sense when you see it on the build platform. Okay. So as I was saying, like it might make sense. Just stick the flat part right to the build plate. It's going to work. Some resins stick so hard to build plates that if they're not built up on a raft or they're not supported at all, actually the print doesn't work out. So that's why I'm going to just go ahead this first time. We're going to try it 5 different ways. And then I just know how I'm going to print these types of prints every single time going forward. So here's the first thing we want to do is, okay, we go to the supports field. I go to the default support, and the default support is a 0.7 millimeter sphere. That's what attaches to your print object. And a 0.9 millimeter diameter, let's call it tree trunk, right? If you're printing a large, heavy object, you may want either more supports or stronger supports. But in this case, so this is a default. This is kind of set by a lot of work Shining does on each resin to make sure it's compatible with the printer and works really well. But the one thing they can't do is they can't anticipate every single thing you're going to print. Like I'd want a slightly different support if I was, for instance, printing a whole horseshoe gingiva mask, like an entire arch of gingiva mask, because it's going to be a larger object. It has more mass. It's going to want to break off supports easier. Whereas with smaller objects, I want the least amount of supports possible because that'll give me less cleanup to do after I print. So what I'm going to do here is I'm going to take this flat object that's flat down and this one that has the gingiva surface down, and I'm going to go ahead and generate 0.7 sphere by 0.9 supports. Okay. And then I'm going to take these other two different variations in how they're facing. And on this one, what I'm going to do is try and reduce this sphere down to 0.5. Now, why is this important? The smallest the connector I can put on this object, the easier it is to break the connector free of the object without leaving any of the connector on it and without changing how my model looks. Because I'm trying to print something that's as accurate to the real life scan as possible. This definitely comes up when you're printing crowns. Here's the other thing I can change. The other ones I printed with a spacing. That means the space between the supports was 2 millimeters. Well, I think these objects are pretty small, pretty delicate. And I don't think they're going to need a lot of support. So I don't think we need a lot of number of supports. So I'm going to space them out a little more. So here's the changes. This one's going to be done at 2.5, 0.5 and 0.9, generate. Now, if I'm wrong, what's going to happen is I don't have enough supports and my connections aren't strong enough, meaning that sphere connecting them isn't strong enough. And what'll happen here is the model will break off during printing, fall off. It'll be down in my resin tray and I'll have to fish it out of there. Or pour my resin through a filter to clean out any broken off pieces so it's not in my next print. But I'm just going to do this the first time. I'm going to find out, because by finding this out, I'm going to make all my future printing easier. I'm going to decrease my resin use and decrease any of my labor time I have in cleaning up the print after printing. So I've done this, and for the sake of, if you do this as a test, I would take notes of what you did. But also, if you've confirmed you like how a support prints, you can go ahead and save these changes you made to a little custom print. And when I say them, I like to throw some information in here. So I say, Gingiva 0.5 -0.9 -2.5. And that way, if I'm looking at my drop-down options for supports, I just quickly know, hey, this is a 0.5 sphere, 0.9 thickness trunk with 2.5 spacing. Hit confirm. All right, and that's saved. Now I just hit next. And normally I would hit send, and it's going to go ahead off and send it to my printer. But my printer's actually already printing this right now. So what we're going to do is wait till it's done printing. I am using Shining's older workhorse printer. It's the L4D. I really like my printer. I've been printing on it for 3 years now. It's done, thousands of prints for me. The resin tank is really excellent, holds up really well. And the film kit, every resin tank at the bottom of it has a clear film. That's what the UV light actually shines through to do the curing process. Obviously, the bottom of the tank has to be clear, because otherwise, how would you get a curing light up through it to actually do the 3D printing? But that film at the bottom of a resin tank is actually slowly damaged by 3D printing. You'll actually see it. It'll get dimples in the plastic and so on. And what I do is I occasionally just pick the whole tank up over my head, or kneel down and look up at it. But I want to look, even if it's filled with resin, I want to look up at it from the bottom and see how dimpled that plastic is. And if it starts looking pretty roughed up, usually I find, depending on what I'm printing, 50 to 100 prints. For some objects, I've seen even less. And especially you can destroy one really quickly if you've accidentally had a model break off and it falls down in your resin, because then the build plate will come down and crush little bits of that model into the film when there isn't supposed to be anything there, in the initial phases, which is why it's important to keep your resin cleared out of broken pieces. So if you ever have pieces break, when you take your models off of your build plate, always inspect to see if one of your models fell off and is down in your resin. If it is, the easiest thing to do, especially with a Shining 3D printer, is you can run this feature called Resin Cure. And what it does is it cures a whole bottom layer of resin, so that any parts or anything that's fallen off into your resin, they all sink to the bottom, right? So now they'll end up all cured to this bottom layer you just cured, and you can just peel it off the bottom, takes all the trash out of your resin, and so on. I do this because I usually keep 3 or 4 tanks going, and each tank has a different resin in it. And the only time I ever pour the resin back in the bottles is when I'm changing out the film on my resin tanks. So that's another thing. If you're using a different style printer other than a Shining printer, make sure you know how much it's going to cost you to replace resin tanks, and find out, can you just replace the film, or do you have to replace the whole tank? Because that'll dramatically change the cost of 3D printing in your practice. Because you could end up with some of the 3D printers. Not only are they more expensive than Shining 3D printers, but their consumables frequently will basically make it to where if you're using the 3D printer, even on a moderate basis, you're paying as much in consumables. And I'm not talking about resin. I'm talking about these other parts of the 3D printer. You'll end up paying as much in those parts as you do for the whole printer in a year. So it can be very expensive. Like the film replacement kits on my L4D, I think are $130 or something like that. And I was just working with a client, helping them out with a 3D printer setup they had with a different company's 3D printer, one of the fancy ones that, automatically cures and washes and all this jazz or something like that. It like injects the resin into the tank for you and all this stuff. So you never have to handle the resin. And some of the components on that printer are literally thousands of dollars. We at least got a functional setup for them so that everything's working. And I think if they try and use it really efficiently, it at least won't be more expensive than had they just gotten everything done by a lab and shipped to them. But between the printer costs and the cost of consumables and the resin's really expensive because it comes in these cartridges, their ongoing cost of 3D printing almost doesn't make sense. I mean, it's taken something that really should save your practice some money as well as adding some functionality to your practice, and it can literally just cost you more money than just having a lab do everything for you. So it's something to keep an eye out for and just take into consideration. So that's printing. I'm going to come back to you when it's done printing, and we're going to go take a look at the build plate before we wash it so that you can see what I'm talking about how these things print. And we'll also get an idea of which of my print styles is going to work the best for us. So I'm excited about that. I look forward to showing it to you. Okay, our printout is all done. And I went in and I took some pictures as the print was completed. This first picture here is how they look on the build plate before the wash phase. So you can see there's still a lot of wet liquid resin stuck to them. This is what we wash off in the alcohol during the wash phase. And we can see the print on the front is the one stuck directly to the base plate. The print on the right was with support stuck to the flat part of the Gingiva mask model. And this print up top here is with the supports on the print on the top of the picture is with the larger supports done to the Gingiva side. Now this print in the center was with the diameter of the sphere cut down in half to 0.4, and so was the print to the left. So you can see what we're seeing here is even when I cut my support size down by half, everything stayed affixed to the build plate and everything printed correctly. This is good news. This means there's no reason to print with the thicker supports. Always want to print with the thinnest supports I can get away with because it's going to leave the least amount of material stuck to my model. All right, now I move these into the wash basin. Shot a little video of what that looks like. You can see here they're in my wash basin. This is loaded into the fab wash unit Shining has. You load the whole build plate into it. And when I hit cut and wash, what it's going to do is cut those models off of the build plate, drop them down into a basket, and then it's going to run both a ultrasonic wash and a motion wash with the alcohol down in the base. So as I hit the start button, what happens is the unit will start descending down into the wash station. And then once it gets down to the right height, it lines itself up, and a cut blade comes across, cuts it free from the build plate, and drops things into the wash tank and starts washing your prints. Now, the nice thing is it does not wash your build plate. This is actually a benefit to not wash the build plate, because that means after your 10-minute wash cycle, you can pull that build plate and put it right back into your printer to print another model. If it washed it, you need to dry it off, clean it up and everything before going back in. When I want to wash the build plate, I actually load it into a separate unit I have that I just toss. I put the whole build plate in there and run a wash cycle. Okay, so now I took a video of the models parts after I took them off of the build plate. And the first thing I noticed, or after they went through the wash cycle, the first thing I noticed is these top two in this video. Actually, the supports were actually loosely connected enough that actually the models disconnected themselves during the wash station, which was nice. I didn't even have to disconnect the supports. They came clean right off. Then I'm going to move over here. This center model, this was the one that was stuck right to the build plate. This model was extremely clean, very easy to use. Once this is cured, this will need no touch up at all. It's ready to rock and roll. This will probably be my preferred way to print these Gingiva mass models, is just stick the flat side directly to the build plate because it works so well. And then the far right ones, these were also excellent. So with the default support setting, I also got an excellent print. They also broke off of the model relatively easily. There's probably just a couple of little extra nubbins on it that I don't want on there. And with a soft tissue resin, it'd be very hard to buff them out. Now, whether or not it would impact at all the use of this in the model, probably not, because none of them are in the area I'm most concerned about for determining how like a crown is going to seat up against the soft tissue. But that being said, why use supports? You're just wasting resin if you can just put the flat part directly on the build plate. Tried to get you a nice clear video of each model so you can see how these turn out. You can just ignore that some of them seem shiny and some don't. That's just whether or not I dried them off with a paper towel or not. Now I'm going to load all these models into my curing station, fire it up. It takes about, I tend to overcure. Every resin has a different curing time, and usually it's written right on the bottle. If you're using Shining resins, the Shining Cure Station will tune right into the printer and pick a default setting. But I tend to use the custom setting a lot because I like to cure things differently. Really small objects don't need the same amount of time to cure as very thick objects. And, it doesn't take much to get a feel for this and know how long you want to cure something. When you pull it out of there, you can tell whether or not you've completely cured it or not because of how tacky it is. Okay, here's a picture of my final piece. It's cured. It's ready to go into the model now. It came out really nicely. All the sides were really clean. It was very precise. Looks exactly like the model I was trying to print. And then the final phase is I went ahead and I seated it into the model. I'm going to go ahead and make this a little bigger for you. You can see here it is. I printed the models with Shining's model material. It always prints really well. I like to use Shining resins with my Shining printer as often as possible. One, because the pricing's excellent on their resins. But two, they just print really, really well. They're excellent resins. So I printed this model. I think it actually is with an older resin that they've now end of life, the Ortho Dental Model 01, and now they have a 02. Similar models, they just increase some of the performance qualities of the resin. So I printed my dental models, and then I went ahead and I put in my gingiva mask, and now this model's ready to use. Well, I hope that this video is a big help for you. I know a lot of people want to be able to print these types of models, these separated models, and there's a lot of confusion as to how to get the design work done, which we pointed out in the beginning. Go ahead and use Shining's design services. They're incredibly inexpensive, and the amount of effort it would take to learn Exocad to do this, plus the $10,000 price tag of Exocad, I mean, it's kind of hard for me to understand why anyone would want to do that. And then on top of then, go ahead and move your models into Accuware, which is the print software for Shining. It's very straightforward. Like I said, with these dental models, the what you see is a tan colored model. They were what's called a hollow model, meant the inside of them is hollow. So I did print those with supports. If it was a honeycomb model where it's not hollow inside, you just stick them right to the base plate and print them. And then as we discovered when we were printing with this Licrete Gingiva mask, which this is what we printed with. It was the Licrete Gingiva mask. When I printed with that, using the default resin profile in Accuware worked great. I found that sticking the Gingiva mask model directly to the build plate gave me the best results because I didn't have to clean anything off of it and got a perfect model print. Overall, I hope this helps you understand how to do just another thing with your 3D printer in your dental office. For me, I want all this equipment to be as functional and easy to use for dentists as possible. I think it's exciting to get to move some things back into the dental office and get to produce some things that can be a creative endeavor and super helpful clinically. So I appreciate your time. And, as always, if you want to like and subscribe to the videos, I try and do these whenever possible. Whenever I have a new process come across my desk that someone wants to know how to do, I go ahead and try and make a video of it so I can help as many people as possible. So it's Friday today, so have a great weekend.